Hi everyone, and welcome to the course. This course is on Siemens TIA Portal Asset-Oriented Programming, and the course is designed to take you from knowing nothing about structures, UDTs, and the asset-oriented approach in TIA Portal through to developing your first project in that structured manner. So to begin with, the course is set up with theory elements and then practical elements. So we go through the theory first in a sort of diagram approach and discussions, and then we'll switch over to TIA Portal and actually apply those theories to actual code and projects, so we can see how this stuff goes together. So let's take a look at the basics of what is asset-oriented programming. So essentially, the bare bones of asset-oriented programming is that each asset has its own data set and associated management system. So that's a function block that uses a UDT basically to not only hold the asset's information in one place, but to standardize the data and then use a standard function block with that standard data to ensure that every single asset operates exactly the same way and is ready to be packaged up into a library. So here we have an example of a data block, which is represented by these in our project tree. And each one of our data blocks represents an asset or bespoke data for that asset. So we can see here that we have M1A IF1, which is flow meter 1 on system A. And then we have M1A IF2, which is flow meter 2 on system A. And we have the same thing for pressure transmitters, temperature transmitters, and each of these data blocks has a UDT within it that represents or handles the data for that asset type. So flow meters have a flow meter UDT, pressure transmitters have a analog UDT, and you'll find that the temperature transmitters also have a analog UDT, so they share the same one as the IP1 and IT1. And the only reason that we have them in two different areas is because from a project management point of view, that's a nice thing to do. And then we also have bespoke. So IF1 here has the standard flow meter UDT, but IF1 bespoke is an extension of that UDT, but we don't want other flow meters to have those parameters and those set points associated with them. So we have a bespoke data block that just handles the extension of IF1. If we come and have a look at what one of these UDTs looks like, this is an example of a UDT for a flow instrument. So we can see that they also have other UDTs in them, and then a load of single variables or arrays that make up the data set for this flow meter. Now we'll go through this in more information when we actually run the course. This is just the introduction, remember, but it's a good idea to get a handle on how this stuff goes together, so it's not a surprise when we're actually running through it later. So essentially, an asset has a data set, and that is a data block and a asset type definition, or UDT, put together, and that creates our data set, which we saw earlier. And then a data set is put together with a function block, which I call the asset manager, and that comes together to make an asset object. So an asset object is your function block with a UDT containing all of your asset data set being passed to the asset manager. And you can go one step further. We can have lots of asset objects that come together to create a structured system, whereby once all of those have been added to a library or versioned or signed off, tested, however it is that you decide you want to manage your objects, we can therefore say that the structured system has been tested, signed off, and is ready to be commissioned on site or put into a library for other people to use. And if you go ahead and edit one of your asset objects, if you're using a library, this is, your structured system will also update. So if you have say a basic containerized sand filter, which has 4 different instruments on and a pump, for example, they are made up of your asset objects. They come together with additional logic and interlocks and things like that to create a structured system. But if you edit one of them and you're using libraries, your structured system would also become would also get edited, and versions would be updated automatically by the library management system. And we'll explore that through the course because it makes a lot more sense when we're actually going through the motions of saying, okay, a core asset object needs to be updated. How does that affect systems that rely upon that? And essentially, that is it for the basics of asset-oriented programming. There's a lot more how we get different asset objects to interact with each other, how we structure our data sets, how we manage interlocks, extension, and bespoke parameters, and things like that, and just how big you can make these systems, which we'll cover through the course. But as for a high-level overview, it essentially starts with you have asset objects that containerize everything. That's all of your input I/O, your output requests to I/O, and all of the alarm management, everything all exists within one of these asset objects. And the end goal for this is that you essentially have a pre-built library of signed off and healthy asset objects that you can just drop into your program, and everything that you need to get that asset up and running is already created. You've literally just got to plug in your I/O and that's it.